Hi guys, today we are discussing calculation on relative atomic mass and relative molecular mass. Now, this very topic is one of the major topics on calculation and chemistry. In our previous lesson or exposition, we discussed atomic mass and molecular mass, which is also known as relative atomic mass and relative molecular mass or relative formula mass when compared with carbon 12 atom. Now, we discussed the fact that every substance around us, be it a compound or a mixture, you know, is made up of different things. We discussed the fact that substances can be broken down into, elements and mixtures, into atoms, and so on and so forth. And we also discussed the fact that when atoms come together, they end up forming elements and most times molecules. Elements could exist as individuals. They could exist, in a single state, but there's no way molecules could do that. And most times molecules exist in a combined state. We also discussed the fact that for the mass of an atom to be gotten, mainly protons and neutrons are combined together because of the fact that they mainly have about one atomic mass unit, while an electron is 1 over 1,868 part of one proton atomic mass unit. So most time when it comes to getting the mass of an atom, we don't really consider what an electron is. So today we're going to be solving a couple of questions. So here's the first question we're going to be looking at today. What is the relative molecular mass of copper 2 tetrasulfate 6 heptahydrate? Now this is copper 2 tetrasulfate 6 heptahydrate. This hydrate here is water. So hepta is 7 crystals of water. Now before we can solve this, first of all we need to get the chemical formula of copper 2 tetrasulfate 6 heptahydrate. Don't forget we are talking about copper and sulfur and probably H2O, which is hydrate, as the major players here. So first of all, let's write out the chemical formula. Copper 2 tetrasulfate 6 heptahydrate is C2SO4. Hepta is 7 molecules of water. Hydrate means water. So that's what we have, 7H2O. That's what we're working on. We are asked to get the relative molecular mass of this very compound. Now, before we could get a relative molecular mass, first of all, we need to know our relative atomic mass. Each of these elements, the atoms, here we have one atom of copper, one atom of sulfur, 4 atoms of oxygen. Here we have 2 atoms of hydrogen, but when you relate 7 to it, you end up with 14 atoms of hydrogen, 7 atoms of oxygen. So first of all, let's get to know the mass of each atoms of the element we have right here. So for copper is 63.5, approximately 64 units. Then sulfur is 32, oxygen is 16, hydrogen is 1, and I think we're done with that. So we have copper 64, sulfur 32, oxygen 16, hydrogen is 1. So how do we get the relative molecular mass or the molecular mass of this very compound? Now we're going to solve it this way. We have each of the atoms already, one atom of copper, one atom of sulfur, 4 atoms of oxygen. While right here we have altogether 14 atoms of hydrogen, 2 times 7. This 7 here is for all the H2O that we have here. Here is an atom of oxygen, but altogether is 7 atoms of oxygen. So since you have one atom of copper, that will be 1 times 64. I have 1 times 64 right here. Plus, then sulfur, also one atom of sulfur, 1 times 32. Then oxygen is 16. You have 4 atoms of oxygen there, 4 times 16. Then plus, then the 7 right here stays outside. Then we have 7 outside, and 2 atoms of hydrogen. That's 2 times 1 hydrogen is 1. Then plus, the right here, 1 atom of oxygen, 1 times 16 also. So what do we do next? We open up the bracket. 1 times 64 is 64. 1 times 32 is 32. 4 times 16 is 64. Then plus, the 7 out here. 2 times 1 is 2. 1 times 16 is 16. So you're going to add up all this. 64 plus 32 is 96. 96 plus this is 160 plus 7 2 plus 16 is 18. So 160 plus 7 times 18. What do we have there? 126. 7 times 56. Keep your 5. 126. So 160 plus 126 will give us 286 gram per mole. Now one thing I want you to know is that when it comes to the unit for molecular mass, it's always in gram per mole, because when we talk about mole is mass over molar mass. So by the time you do your substitution, you end up with gram per mole for the unit for molecular mass. Unlike atomic mass, which is atomic mass unit AMU. So that's that, as simple as ABC. Question 2. What is the molecular mass or the related molecular mass of ammonium sulfate? Now this is another compound. The chemical formula is already written. Ammonium sulfate, ammonium, NH4. We just have a valency of 1. Then SO4 tetrasulfur 6 has a valency of 2. So by the time you bring them together, don't forget we've worked on this in one of our previous lesson. So NH4 is 2, then SO4. NH4 has 1, I beg your pardon. Then SO4 has 2 valencies. So you just bring them together, and we have NH4 to SO4. So don't forget, this very 2 here affects everything right here in the bracket, just like this very one here, where we have 7 molecules of water. So how do we get the molecular mass of ammonium sulfate? So first of all, let's get the atomic mass of each of the elements that make up this very compound. So nitrogen is 14, then hydrogen is 1, sulfur, as stated up there, is 32, oxygen is 16. So these are the things you're going to be using. Don't forget that we're talking about the mass of a molecule, molecular mass. There's no way you can get a molecule without having atoms in a combined state. So atoms come together to form a molecule. So this is a molecule. We can say this is a molecule because we said it in our previous lesson. The molecules could be identical or non-identical. So where hydrogen is nitrogen, I beg your pardon. Nitrogen is 1 atom. Then hydrogen is 4 atoms. So we can say this is a molecule of hydrogen. And all together here, we can call this a molecule because we have more than 1 atom. So first of all, yeah, we have 1 atom of nitrogen. So but we have an external 2 atoms that really shares out on each of them. So altogether, nitrogen here is 2 atoms of nitrogen. That will be 2 times nitrogen is 14 atomic mass unit. You have nitrogen has 14. So you have there 2 times 14 here, plus then you can say hydrogen altogether is 8. So that will be 8 times 1. Then plus sulfur here just 1 times 32. Then oxygen is 16 times 4. So we have everything set out. We've gotten the molecular mass already. Once we know the atomic mass unit, the next thing you have to do is to get to know each of the atoms. That's the atom that each element has. Then from there, we'll put them together, and we're done with our molecular mass. So 2 times 14 will give us 28. 8 times 1 is 8. 1 times 32 is 32. 16 times 4 is 64. So just add all this up, add them up. 28 plus 8 is 36. 36 plus 32 is 68. 68 plus this will give us 132 gram per mole. So as easy as that. Okay, guys, at this very point in time, it is time we got ourselves tested to know how much we've got from today's lesson. So we have a couple of questions as a take home. Now here are the questions. Find the molecular mass or the related molecular mass of the below compounds. So the first compound is calcium hydrogen triisocarbonate 4. Calcium hydrogen triisocarbonate 4. You have to get the molecular mass. The first thing you have to do is to write out the correct chemical formula before you write out the molecular mass. So the next is zinc nitrate hexahydrate. Zinc nitrate hexahydrate. Then you have to write out the chemical formula first. Then you get the molecular mass of this. So the very last question is sodium dioxoaluminate 3. Now you have to get the molecular mass of this. First of all, you have to write out the correct chemical formula. So at this very point in time, we're drawing the curtain of today's lesson. So if you found this lesson resourceful, please subscribe to this very channel and share this lesson with others. See you in the next lesson. Thanks.